Welcome back. In this video, I will explain you the coding in C for implementing doubly linked list using XOR. In the previous video, I have explained to you that this yellow region will carry the XORed value of the previous address and the next address. So, the previous address will be 0 and the next address will be 478, and these two will be XORed in binary form and it will be stored here in this node. Similarly, 743 will be the prev and 521 will be the next here. These two will be XORed. Here 478 and 291 will be XORed, and here 521 and 0 will be XORed because there is no node after this node, right? The logic will be like this, that if you have this address of A, that is 0, 0, 1, 0 and 1, and if you have the address B, that is 1, 0, 0, 1 and 1, and if you perform bitwise XORing between these two addresses, then you will get this. And if you interchange so that the XOR comes over here, and if you perform XORing between the address of A and the XORed value here, then you will get B. And of course, if you perform XORing between this XORed value and address of B, then you will definitely get this A, right? If you stand at this node at 743, then you have the XORed value between the previous address and the next address like this. Now, if you want to move from this node to the next node at 478, then you arrange the previous address, which is of course 0, and you perform the XOR operation with this XORed value that has been stored previously, and you will get the address 478 as a result after this XORing, right? So you can move from this node to this node. Similarly, if you want to move from this node at 478 to this node at 521, then you arrange previous address, that is 743, which is the previous node now, and you perform the XOR operation with these XORed value, and you will get 521 as a result, right? Now suppose the start is there and it is pointing to the first node at 743, and at this moment there is only one node. So in this yellow region, you store the XORed value of the previous address and the next address. Since previous address is null and the next address is also null, so 0 has been stored here. Next, you create one node and point it by mu, and suppose the node has been created at 478. So you replace this 0 with 0 XOR mu, because 0 is the previous address and mu is holding the next node's address. So you XOR these two addresses and store the value here. To perform this, you take the temp pointer and initialize it with start so that the temp will be standing at 743 initially, right? Next, you update this yellow region with temp XOR 0, because temp is the previous node and 0 is the next node, so it will be looking like this. Next, you add one more. mu is pointing to the node at 521, and this is the list that is existing at this moment, and this node at 478 is the last node. Now what you should do is that you bring temp over here at 478, which is the last node, and bring prev over here, which will be following temp, that is prev will be always one node behind temp, right? So you have three positions here, you see. This one is temp, this is the last node, mu is here with the new node's address, and prev is here just behind temp with the node's address as 743. So you update this area, that is 743, and mu. You also update this region, that is temp XOR 0. Let us see the code now. Here you see the header file, that is stdint.h. Now we need this header file because of this data type here, that is uintptr_t. This data type is required to store the XORed value in each node. And beside this header file, you need the other header files as usual, that is stdlib and stdio. Okay. Now here is your structure. There is struct node. We have given the name node, and this is the data part, and this is the variable of this uintptr_t type, and the name of the variable I have given here is XORed prev next, because you are XORing the prev's address and the next address. That is why I tried to give here a relevant name, that is XORed prev next, right? Okay. Here is your main in choice, one for adding new node, one for display, and one for exit. Okay. And here you have all set to null. Okay. So these pointers are all of struct node star type. So start will be pointing to the first node, mu will be pointing to the new node, prev will be pointing to the previous node from where you are standing, and next will be the address of the next node, and temp will be the pointer at which you are presently working on, right? Okay. Here is your while loop, and you have this 1 for add node, 2 for display, and 3 for exit, and you have this choice here. And if it is 1, then you create one node and point it by this mu pointer. Okay. You take data from the user and store it inside mu's data variable. Okay. And set the mu's XORed prev next, that means this member, to 0. Okay. So your new node is ready to be inserted into the list. Next, you check this, that if start is null, then this mu will be your start. Now, this is the else part, that means start is not null. Then what you should do? You set temps to start so that temp will be pointing to the first node, and you set prev and next both to null. You have already set prev and next to null, but still I am giving here this statement because this is the while loop, and it will return over here to ask you whether you'd like to add a new node, or you want to display, or you want to exit from the program. So in that case, this prev and next must be null initially, right? Now look at this figure. This is the first node and this one is the last node. And you have a new node here which is pointed by mu, and you set prev and temp like this. That is, prev is null. The temp is pointing to the first node due to this line, that is temp equal to start, and next is also set to null, but after this line you see that next equal to struct node star, this is the typecasting, and you are XORing prev with temp's XORed prev next. So you XOR these two and store it inside the next. Definitely you will get the next address. You must typecast prev with uintptr_t type. You don't have to typecast here because your XORed prev next is already uintptr_t type. So this XOR operation can be done, and after that the result will be of uintptr_t type, but your next pointer is of struct node star type. That is why you have to typecast again the result to struct node star type, right? Now, next can hold this XORed value here, right? So your next will be standing over here. Now, you run a while loop here and you say until next does not get to null, you run these three statements. What is there? You set prev to temp and temp to next, like this. Now you compute new next, that is, use the prev's address, use the temp's XORed prev next, that means prev's address is this one, temp's XORed prev next is inside, so you perform the XOR between these two and you get the next. So you can see that previously prev was here, temp was here, and next was here. Now prev is standing on this node, temp is standing on this node, and next is standing on this node. Now you check whether next is null or not. You can see that next is not null. So you run these three statements again. Prev will be temp, temp will be next, and the new next will be computed by XORing the prev and the temp's XORed prev next, like this. So it is not null. So you proceed like this. Again, you proceed like this. And one more. Now your next is null. So the loop will get stopped and your temp will be standing on the last node and prev will be standing just behind temp, right? So what you have to do, you update the temp's XOR prev next variable. So temp's XOR prev next, that is a new value of temp's XOR prev next will be prev, that means this one, XORed with mnew, that means this one. So prev's address and mnew's address will be XORed and stored inside this node. So this is the line. And you have to update the mnew's XORed prev next also. So it is simply copy this temp over here because the temp is the previous node now in regard to mnew and there is no node after this mnew. So it is 0. So if you XOR temp's address with 0, then it returns temp's address only. So that is why I have written here temp, that is simply copying this value of temp to this XORed prev next of mnew. So your new node has been added to this list. Now we will see how the display actually works. You set temp to star, you set prev next to null, and here you write while temp itself not null. Previously, when you are adding new data, you check whether your next is pointing to null or not. And during display, you set whether your temp itself is getting null or not. So if your temp is not null, then you can print temp's data, you can print temp's address, prev's address, next address, and temp's XORed prev next also. You can print it like this. Of course, you use this %u because these are all addresses. Next, you compute new next here by XORing prev with temp's XORed prev next. You print the new address of next. You move prev to temp so that prev will be getting new address now. You move temp to next, so your temp's new address will be here. And this loop will run again until your temp gets null. So this is your program for implementing doubly linked list using XOR. In the next video, I will go for introduction to circular linked list. Thanks for watching and take care.